Write an indirect proof. Given line L is not parallel to line K, prove angle 3 and angle 5 are not supplementary. To write an indirect proof, the first step is to assume temporarily that the statement you want to prove is false by assuming that the opposite is true. In this case, you want to assume that angle 3 and angle 5 are supplementary. So you can begin your indirect proof with the statement, assume temporarily that angle 3 and angle 5 are supplementary. Next, the second step of writing an indirect proof is to reason logically until you reach a contradiction. To do this, first notice on the diagram that line L and line K are cut by a transversal, and that angle 3 and angle 5 are consecutive interior angles. Now, if line L and line K are cut by a transversal so that the consecutive interior angles, angle 3 and angle 5, are supplementary, then by the consecutive interior angles theorem, line L is parallel to line K. This contradicts the given information. Now that you've reached a contradiction, the third step is to point out that the desired conclusion must be true because the contradiction proves the temporary assumption false. So you can conclude the indirect proof with the statement, the assumption that angle 3 and angle 5 are supplementary must be false, which proves that angle 3 and angle 5 are not supplementary. Draw an obtuse isosceles triangle. Find the largest angle and the longest side and mark them in red. Find the smallest angle and the shortest side and mark them in blue. What do you notice? To draw an obtuse isosceles triangle, draw a triangle that has one obtuse angle and two congruent sides. For example, you could draw the triangle as shown. Now, in this drawing, the largest angle is the obtuse angle and the longest side is the base of the triangle. As you can see, the longest side and the largest angle are opposite each other. Now, because this triangle is isosceles and has two congruent sides, the angles opposite these two sides are congruent by the base angles theorem. So, the base angles of this isosceles triangle are congruent. Therefore, there are two congruent smallest angles. In addition, the two congruent sides are the shortest sides. As you can see, the two shortest sides are opposite the two smallest angles. List the angles of triangle ABC in order from smallest to largest. From the given diagram, you can see that the sides of triangle ABC, listed in order from shortest to longest, are side BC, side AC, and side AB. Now, the triangle longer side theorem states that if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. In triangle ABC, the angle opposite side BC is angle A, the angle opposite side AC is angle B, and the angle opposite side AB is angle C. Therefore, by the triangle longer side theorem, the angles of triangle ABC, listed in order from smallest to largest, are angle A, angle B, and angle C. List the sides of triangle ABC in order from shortest to longest. To begin this problem, you first need to find the measure of angle C. To do this, you can use the triangle sum theorem. By the triangle sum theorem, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. From the given diagram, you know that the measure of angle A is 59 degrees and the measure of angle B is 61 degrees. So you can substitute these values into the equation. Now, to solve for the measure of angle C, you can first combine like terms on the left-hand side of the equation. 59 degrees plus 61 degrees gives you 120 degrees. Next, you can subtract 120 degrees from both sides of the equation. This gives you the measure of angle C equals 60 degrees. So, the measure of angle C is 60 degrees. Now that you know the measure of the three angles, you can list the angles in order from smallest to largest. The angles of triangle ABC, listed in order from smallest to largest, are angle A, angle C, and angle B. Now, the triangle larger angle theorem states that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. In triangle ABC, the side opposite angle A is side BC, the side opposite angle C is side AB, and the side opposite angle B is side AC. Therefore, by the triangle larger angle theorem, the sides of triangle ABC, listed in order from shortest to longest, are side BC, side AB, and side AC. a triangle has one side of length 6 and another side of length 15. Describe the possible lengths of the third side. To begin this problem, first let x represent the length of the third side. Next, you can draw diagrams as shown to help you visualize the small and large values of x. Now, by the triangle inequality theorem, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So, in the triangle on the left, for small values of x plus 6 must be greater than 15. To solve this inequality, you can subtract 6 from both sides of the inequality. This gives you x is greater than 9. So, x must be greater than 9. Next, in the triangle on the right, for large values of x, 6 plus 15 must be greater than x. When you combine like terms on the left-hand side of the inequality, 6 plus 15 gives you 21. So, 21 must be greater than x, or x must be less than 21. Therefore, the length of the third side must be greater than 9 and less than 21.